Today we are going to look at JSON document validation as found in MySQL 8. I'm Dave Stokes. I'm a MySQL community manager, and I'll be your guide for this little session. I am talking mainly about a product that's been out in general release. If I talk about anything accidentally about something from the future, take those words with a grain of salt. I do not have any perfect knowledge of the future products. And by the way, remember that MySQL 5.6 reaches its end of life status on February 2021. So if you're running 5.6, please plan to upgrade. If you're running something earlier, please upgrade, hopefully to MySQL 8.0. By the way, for those of you who don't know what MySQL is, it's a 25-year-old relational database. It's free under the GNU Public License version 2. We also have a licensed enterprise edition that gives you, besides that phone call to be able to call when you have problems, better monitoring software, improved backup, at-rest encryption, data masking, a firewall that learns your queries and then spurns the queries that don't match that, key management, and other stuff. We're also a NoSQL JSON document database, and we have a lot of other products like Router Shell, NODB cluster that work to give you safety with your data. So, JSON. JavaScript object notation is the preferred data interchange format for most programmers. Many years ago we were using XML and it got ugly. JSON's a little easier on the eye and a little bit easier to read and parse. Now relational databases, the big vendors have all gone out there and mostly have added JSON data type as a native data type. This gives you a little bit more powerful processing, and they've all written a series of functions, and we're going to be talking about one of those functions today. The great thing about having a JSON data type is it's great for saving JSON data. So if you have a Internet of Things device that gets a new refresh of the firmware and something starts giving you barometric pressure and longitude and latitude, you store that right in there without having to go out and reformat your table. It's also great as a column type for highly mutable data. So if things are changing rapidly and you don't have time to rebuild your table structures, it's great for that. Also, it lets you reduce many-to-many joins. So if you are doing a dive from a table into an index to find an entry in another table that leads you to yet another index and table ad infinitum, this will save you a lot of dives into the data. It's 1 or 2 reads instead of 4 or 5 or 6 or 7 or more. Now, JSON's great, but traditional relational database management systems have ways to ensure rigor. Trying to put a text string into an integer field, you're going to get an error. There are other things out there that relational databases can do to make sure you get the bad data before it gets into your database. The other problem is that JSON data types usually do not ensure rigor. What do I mean there? Well, I'm coding email addresses as E uppercase male. Person next to me is encoding that is all lowercase email. Someone else is doing it as E- mail, E_ mail, electronic mail, all that sort of stuff. There's no way to make sure that the keys with their values come in, that they're in the format that you want. Also, traditionally you can't do range checks. If you're selling something that can only be sold to adults, you need to make sure that it matches that pattern. Type checks. What if you're expecting a numeric value like someone's birth year and suddenly you get the string Texas? Doesn't quite work. Also, traditionally JSON data types don't have required fields. So if you need someone to have that email address in there, you need to do something programmatically. Unless, of course, you're following the recommendations of JSON-schema.org. These good folks are trying to figure out a way to get this adopted by the Internet Engineering Task Force as a way to do all those things that I was complaining about that traditionally relational databases don't have with the JSON data type. Now, the first function I want to show you is JSON schema valid, which returns a 1 or true if the document passes the exemplar schema. And on the left there, you see we have a variable called $s. This is our exemplar. This can be a document from a column in a table. It can be here as a variable, as you can see. Now, in this example, we're saying we're going to have a exemplar for an object, and the properties of that object is it's going to be called my age, and my age is made up of a type, which is a number, a minimum value of 18 and a maximum value of 99. Now, I have another document, which we are calling here D, in the variable D, and it is my age with a value of 33. Now, if I do a select with JSON schema valid of those two documents, you see that my age is between the minimum and maximum number. It is also a number, so we get a 1, which means that is true. Something else you can do is you could use constraint checks. Constraint checks will test your columns to make sure what's coming in is what you want. It's much easier to keep the bad data out than have to go back later and find that bad data and update it to a good value. Now, once again, you'll see embedded in the constraint check a JSON schema valid. And in this case, we're doing my age again, and type number, and the minimum maximum age. You also notice that we've named this constraint called my age underscore in range. So if we go to input a value that isn't in range, you see on the right there, constraint check my age underscore in range is violated. Next insert we do, it's between 18 and 99, so it goes in no problem. So you can use JSON schema valid to do these types of data types checks, make sure that we're getting the type we want, range checks, and you'll see in a little bit that we can do it with the required field. Look back to the left, you'll see in bright yellow required. So if you really need to make sure that you have that information in there, you add the word required and whatever objects that you want to make sure that it's in there. Otherwise, their server will reject that data. By the way, in purple there you see my age underscore in range. I do recommend naming your constraints. Otherwise, when things go wrong, you'll get an error message like, constraint check number 4 was not not accepted. It's much easier to find them if you can name them. Also, if you need more reporting detail, where there's another function called JSON schema validation report, which gives you a lot more information on what goes wrong with these range checks. The previous one you saw that we just kind of got that didn't match. This one gives us the details. And with that, I'd like to point you to the MySQL manuals, section 12, chapter 17.7 on the JSON schema validation functions. And with that, I'd like to thank you for tuning in. Here's my contact information if you need me. And by the way, if you're interested in MySQL JSON, you can get my copy of the most popular sellers. Thank you.